All right, so today we're going to talk about density. Now, density is a measure of how compact the mass is. So the bigger the density, the more mass we can fit in a smaller volume. For that reason, we define density as density equals mass divided by volume. So that if you've got a big mass and a small volume, then you get a big density. Now, I've used the symbol d here, but usually people use a different symbol. This is the Greek letter rho. Rho is almost always used for density. What my students have had problems with is just the fact that it's not an English letter. So it's a Greek letter. So they don't know how to write it. So I usually show the students how to write it. It goes like this. So this is our standard elementary school. And we begin at the bottom, up, and little flourish down here. Okay, so that's density. I'm going to use that symbol from now on because that's the one that usually is used in physics books. Okay, so what is the unit of density? Now, of course, we've seen density in chemistry classes, and in chemistry, density is written as grams per cubic centimeter. But this is a problem for physics because in physics, we have to work in SI units, always. Everything must be in SI units. So for that reason, we're going to use kilograms per cubic meter. So it'll be kilograms per cubic meter. All right, now just by converting kilograms per cubic meter into grams per cubic centimeter, we find the conversion 1,000 kilograms per cubic meter is equal to 1 gram per cubic centimeter. So the densities that we're used to looking at in chemistry are going to look a lot bigger in physics. So let's look over here at this table. So we've got a bunch of materials, air, water, iron, copper, silver, lead, gold, and here are their densities. Now look, air, of course, it's not very dense. Its density is 1.3 kilograms per cubic meter. Oh, and notice up here I've got density, rho, divided by, and then in order to avoid having a complicated looking fraction, I write kilograms per cubic meter as kilograms times meters to the -3 power. And of course, that is the same thing. So this is an international convention that people use. So if you look here, we've got air, and then water is 1,000 kilograms per cubic meter. So that means 1 cubic meter of water weighs 1,000 kilograms, which is a metric ton. 2,200 pounds. And then we've got iron and copper, and it goes up from there. Notice how big the density of gold is. That's actually one of the ways that we can tell very easily whether or not something is pure gold, just by measuring its density. It's so dense that it's difficult to find things that are denser than it to just mix with it and make it look like it's got that density. All right, so let's do some sample problems. Our first sample problem is determine the volume of 30 kilograms of lead. All right. Well, I've got an equation for density. It's density equals mass over volume. But that doesn't tell me the volume. It tells me the density. So if I want to determine the volume, then what I'll need to do is I'll need to solve this equation for V. All right. Now, this type of equation is very, very, very easy to solve for V because basically all we need to do is just swap those two. So density equals mass divided by volume. Therefore, volume equals mass divided by density. At this point, all we need to do is plug in numbers. So we'll plug in 30 kilograms divided by the density. I don't know. It didn't give me the density, but it did tell me that it was lead. And I know from my table that the density of lead is 11,350 kilograms per cubic meter. So we'll write 11,350 kilograms per cubic meter. And going into our trusty calculator, we end up with 0.002643 cubic meters. The nice thing about working in SI units is that we really don't ever have to worry about the units except at the very beginning of the problem to make sure that everything is in SI units. Here, it's a volume. So what is it going to be in? Well, it's going to be in cubic meters. So we don't even have to think about it. It's actually a very nice property of SI units. All right, let's go to the next one. Let's determine the mass of 75 cubic centimeters of gold. All right, this problem's trying to be tricky because it gave us a volume in cubic centimeters, which is not an SI unit. So as good physicists, we have to begin by changing that volume into the SI system. So we've got volume equals 75 cubic centimeters. I want this in cubic meters. Well, a centimeter is 10 to the minus 2 meters, and I'm cubing that. So this gives me 75 times 10 to the minus 6 cubic meters. So now I want the mass. Well, again, we've got our density equals mass over volume. We can solve for mass and just write mass equals density times volume. This is gold, so its density is 19,300 kilograms per cubic meter. We'll multiply by 75 times 10 to the minus 6 cubic meters. And that will give us, again, using our trusty calculator, 1.4475. What's the unit? Well, it's a mass. Since we're in SI units, we're in SI units. And it'll be kilograms. Now, I'll just let my students leave the answer like that. But if your physics teacher is a stickler for sig figs, then we've got to change it a little bit. We've got 2 significant digits in our volume. And the density had 3 significant digits because it was 19,300. So that means that we only have 2 significant digits in the answer. And there you go. That's density.